A planet can orbit a bright sun-like star and almost disappear. That is exactly what happened with TRES-2b. By every familiar expectation, a giant planet this close to its star should catch sunlight. It should carry a pale crescent across the darkness. It should announce itself the way planets usually do, by sending light back into space. Instead, almost nothing returns. The star shines exactly as expected. The planet does not. When astronomers measured its reflected light, they found a world darker than charcoal. Less than a few % of the visible light striking its atmosphere comes back. The missing crescent is so faint that the planet seems less like an object beside a star and more like a hole cut from the light surrounding it. That is where this mystery begins. The obvious explanation is simple. Perhaps the planet has a black surface. Perhaps it is covered with something like soot or dark rock. That picture collapses the moment we ask what TRES-2b actually is. It is not a rocky world. It is a hot Jupiter, a gas giant larger than our own Jupiter, orbiting so close to its star that an entire year lasts less than 2.5 Earth days. There is no solid ground waiting beneath the darkness. Nothing can be painted black because there is no surface to paint. The darkness belongs somewhere else. The missing crescent returns here in a different form. At first, it looked like the absence of reflected sunlight. Now it becomes evidence that the atmosphere itself is swallowing the light before any familiar planetary surface can ever enter the story. The planet remains almost featureless. Smooth. Dark. Its shape is easy to imagine. Its appearance is almost impossible. That changes the question completely. If there is no black ground beneath the atmosphere, then what kind of atmosphere can erase nearly an entire planet from visible light? The answer begins with heat. TRES-2b circles only a tiny fraction of the Earth-Sun distance from its own sun-like star. Imagine Jupiter pulled inward until its year lasts less than 3 days. That proximity transforms everything. The side facing the star reaches temperatures above 1200 Kelvin. Hot enough that the kinds of clouds making Jupiter bright never have the chance to exist. On Jupiter, clouds formed from materials like ammonia help scatter sunlight back into space. Here, those familiar reflective clouds cannot survive. The atmosphere is simply too hot. The mirrors disappear. Without those bright cloud layers, sunlight penetrates deeper into the atmosphere instead of bouncing away. Researchers believe vaporized alkali metals, including sodium and potassium, become important absorbers of visible light. Other high-temperature compounds may contribute as well. Exactly which chemicals dominate remains uncertain. But the physical outcome is remarkably consistent. Reflection almost vanishes. The missing crescent returns once more. It is no longer simply a visual curiosity. It has become the signature of an atmosphere built against reflection. Even in this darkness, the planet is not completely without light. Its day side glows faintly from its own heat. Not with reflected sunshine. With a deep, dull red thermal glow, similar to metal that has been heated until it barely begins to shine. The star provides the light. The planet quietly radiates heat back into space. Two very different kinds of light exist side by side. One almost disappears. The other barely survives. That distinction leads to the final contradiction. If a planet reflects almost nothing, how can anyone prove it exists at all? The answer never came from a photograph. It came from measurement. For years, NASA's Kepler space telescope watched the star with extraordinary precision. Not searching for dramatic images. Watching brightness. Again and again. When the planet passed behind its star, astronomers expected the combined light of the system to decrease by a tiny amount. It did. Only a few parts per million. Almost unimaginably small. That tiny change carried enormous meaning. The missing reflected light finally became measurable. The same absent crescent that opened this mystery returned as a scientific signal. Not something visible to the eye. Something visible to mathematics. The evidence changed the entire case. Instead of asking why astronomers could not clearly see the planet, they realized they could measure exactly how little light it contributed. The weakness of the signal became its greatest strength. Every ordinary expectation had failed. A nearby giant planet should have reflected light. It did not. A black planet should have possessed a dark surface. It did not. An atmosphere should have brightened the world with clouds. Instead, extreme heat removed the mirrors entirely. Directly seeing the planet turned out to be unnecessary. Its existence emerged from a precise absence recorded in the light of its star. Researchers continue to investigate exactly which atmospheric ingredients are responsible for making TREES 2b so extraordinarily dark. The balance between sodium, potassium, and other possible absorbers remains an active scientific question. That uncertainty survives. The central discovery does not change. The darkest known planet did not become remarkable because someone captured a spectacular image of it. It became remarkable because a telescope measured what almost failed to appear. The missing crescent remains exactly where it began. Nothing about the planet changed. Nothing about the star changed. Only its meaning changed. At first, the missing light looked like an impossible absence. By the end, it had become the most convincing evidence the planet could leave behind.